Alright, so which of these functions is the same as the original function right here? Well, to compare, let's graph the original function, and then we can sort of imagine graphing each one of these and seeing which one is the same. So actually, what I want to do first is let's ignore that phase shift for a second. We'll do that afterwards. So normally, here's how the cosine function works. Okay, let's see. Now, normally this would be the midline, would be the x-axis. Because of this -2, I know that the midline is going to be shifted down 2. Okay, so that tells me that this is going to be the midline right here. Okay, now the amplitude is 3. So that tells me that the cosine will have to go 3 up from here. So 1, 2, 3 will have to go up to here and down from here. So we'll just go 1, 2, 3. So I'm going to put some extra lines on here. Alright, so it's going to have to go up to here. And it's going to have to go down to here. Okay. What else? Oh, we're going to need to know the period, so we know where to end. So the period is going to be affected by this b value. Okay, we know that the period is always 2 pi divided by the b value. So in this case, that's going to be 2 pi divided by 2. So the period is going to be pi. Okay, so I'm going to put a big old pi out here. And I'll put a negative pi as well for later. Okay, so we need 4 marks. So I'm going to, the halfway point here would be pi over 2. And then in between those, we'd have pi over 4 and 3 pi over 4. Alright, doing the same thing on the other side. Right in the middle here, I will have negative pi over 2, and I'll have negative pi over 4, and I will have negative 3 pi over 4. Okay, so again, if there was no phase shift, then here's what the cosine function would look like. Alright, cosine function starts off at its highest point. Okay, and then it falls to the midline, and then it falls to its lowest point, and then it comes back to the midline, and then it goes back to its highest point. Alright, so a normal cosine function would look like this. Okay, without the phase shift. And I'm just going to do another period of it. So if I kept it going, it would fall to the midline, it would fall to its lowest point, back to the midline, and back to its highest point. So here would be another cycle. Okay, that's what it looks like without the phase shift. Now, I'm running out of colors. All right, this phase shift represents a motion left pi over 2. Okay, it's always the opposite of what it looks. So plus pi over 2 is actually left pi over 2. So if I took this entire graph and I moved it to the left pi over 2, well, you see that pi over 2 is right here, well, negative pi over 2. So if I moved this whole graph to the left, okay, then it would start here, and it would do the same pattern, okay? So it would go like this. All right, so this gray graph is what you would get. All right, if you shifted to the left by pi over 2. And I could keep it going. Let me see if that's enough. I think I will stretch it out just a little bit more. So if I kept going, it would fall to the midline and then go down. So if I just kept following the cosine pattern, okay, this gray graph is what it would look like with the phase shift. In fact, I think I'll go ahead and erase the red part, okay, to emphasize that. So this is the graph of the original function. Now, let's see which of these four functions would be the same. Let's start with the two cosine functions down here. Those should be the easiest to see because they're the same function. Okay, so look at this option right here. Focus on this one. What's the difference between these two? They both have -2. They both have a b value of 2. So the same period. They both have a 3. The only thing that changed is this one has a plus pi over 4 instead of a pi over 2. So that just means instead of being left pi over 2, it's going to be left pi over 4. Okay, so look, I moved the graph from here to the left pi over 2. If I moved it to the left pi over 4, then it would look like this instead. Okay, that's quite a janky looking graph, but you get the idea. This is not matching what we have. So this is not going to be the answer. We can throw this out. Okay, now let's look at the bottom one. What's the difference? The only thing that changed is this one has a negative sign. All right, so this one would be a reflection, okay, over the x-axis. This one would be upside down. That would be the only difference. So if I took this graph and I turned it upside down, then it would look something like this. All right, and again, that's a very janky looking graph, so forgive me. But obviously, these do not look the same. Turning the graph upside down, it's not the same. So it won't be that one. So it's going to be one of these sine graphs. Now, both of these sine graphs have a plus pi over 4 right here. That means they both go left pi over 4. Okay, that means that they will both start right here at negative pi over 4. Remember that the sine function starts at the midline, and then normally it goes up and then back down. So a positive a value would look like this. It would start here, because of the phase shift, it would start here, and it would go up and then back down. Okay, now does that match what we have? No. All right, so that means it's not that one. So this is the only one that's left, but hopefully you can see why it is the answer. again, it has that same phase shift of left pi over 4. That's why we're starting here at this dot right here. Sine always starts on the midline, so I'm starting right here. But because of the negative sign, instead of going up and then down, the negative sign means it's reflected over the x-axis. So that tells me that it's got to go down first and then up. So if we were to do that, starting from here, and if we went down first and then up, oh look, it matches perfectly what we already have. So that's why this is the answer.